Hello, my name is Edmundo Her with Autodesk. I'll be presenting how Autodesk InfraWorks can help retail customers provide and properly control social spacing using microsimulation analysis. Typically, the minimum social spacing distance required is 6 feet. Every owner must provide the proper infrastructure to account for this recommendation. At times, we encourage social spacing and even cancel events. However, we know that key facilities must always remain open, such as supermarkets, hospitals, and some airports. Social spacing is hardly honored in these facilities. Few supermarkets practice social spacing either at checkout counters or prior to entering a facility. Even so, there are no correct logistics to compute the number of people and their spacing. Either way, there's really no social spacing control once customers are inside facilities. We either do or do not. We cannot be oblivious to these guidelines at supermarkets. We must provide social spacing at all times. There are many benefits provided by microsimulation. The most important ones are: it computes the correct number of checkout counters to avoid collapse. It balances the correct number of people to form groups with the time they must be spaced to avoid collapse in the network. Let's never forget that it is always preferred a constant, steady number of groups of people rather than a tsunami of people at once. It provides immediate visual feedback of every simulation run. And since essential goods may be limited to one item per household, retailers can schedule restocking based on egress reports. But the most important benefit is that it always provides safety amongst users by providing social spacing. Everything becomes more critical when social spacing is mandatory or when an economy partially reopens. So how do we do microsimulations? The first thing you need is a raster image. This image can be created either from an electronic drawing file with a supermarket layout or from a simple picture taken from a physical drawing. I then open an existing model using Autodesk InfraWorks, define an area of interest, and select Mobility Simulation. Once I'm in Mobility Simulation, I can import the raster image that now serves as the base for my project. I will be now zooming in, and by measuring key parts of the layout, I understand that space is restricted. Since I have to respect social distancing, flow will then be shifted to one-way traffic throughout the supermarket. Likewise, users will be guided by either gridded guidelines on the floor and or belt barriers. I then place walkways along my desired path, touching crucial stands and food racks, slowing them down to rolling speeds as they navigate throughout the facility. After the layout has been completed with walkways, I define behaviors of people, including their dynamics, social spacing, number of people forming clusters, and their release times. Although movement is restricted to one-way traffic only due to spacing, users are given 2 chances to reincorporate to main traffic before leaving the premises. Notice that there is also a fast route provided for a small percentage of users that do not need to travel the complete set of walkways served by own checkout counters. Simulation is run. Notice that individual clusters of people have a unique color to understand their behavior throughout the simulation. Simulations can be visualized at true speed or fast-forwarded. If proper planning is not carried out, networks can easily collapse. I then open a new model with the same layout, but with new optimized clusters of people spaced at correct intervals to balance demand, social spacing, waiting, walk-in and egress times, supermarket layout geometry, queue lengths, and optimized number of checkout counters, all at once. Likewise, users can create dynamic reports to review behaviors, waiting times, walk-in times, and plan accordingly to always provide an optimum level of service. Thank you very much for watching.